Video, we're going to do a mini test, okay? So these are problems from the AP test, and we're going to attack them as if we were on the test. Okay, so the first one says the function g of x equals that is not continuous at x equals 2 because, okay, so what are the possibilities that x cannot be continuous? G of 2 is not defined, negative. We don't, that has to be a condition, okay, and g of 2 is defined, it's negative 5. G of x does not exist, maybe, we need to check that. The limit of g of x is not equal to g of 2, maybe, we need to check that. G of 2 is not equal to negative 5, maybe, none of the above, negative. Okay, so it's got to be one of these three, so let's check. So the limit when x approaches 2 from the left, since we're using 2 from the left, we're using the bottom one. So 5x minus 13, we plug in 2. So 5 times 2 minus 13 is 15 minus 13, which is equal to 2. Now, notice already that it's not equal to negative 5. Okay, so that's already something that we need to consider. Now, from the right, we're using the top one. So x minus 5. Okay? So the limit, we plug in 2, you get 2 minus 5, which is negative 3. So here, since these two limits are not equal, it's B, the limit does not exist. Okay? Now, why is it not C? Because this is assuming that the limit does exist, but it's not equal to g of 2. But in reality, the limit does not exist because these two are not equal. Okay, so be aware of that difference. Now, this is the second one. This one was the first. It's the second one. Okay, here, notice that x goes to infinity. So what I'm going to do is I'm going to divide each of the coefficients by the highest degree. Now, in terms of the AP, you already know what the answer is. Notice that these two x cubes and x cubes are the same degree. Therefore, the answer is the coefficient 1 over 2. Okay? If you need more details on how to figure that out, go ahead and go to the first video where I explain how to do it. Okay? So next one. It says, for what values of k does the limit exist? Okay? Notice that here, x minus 4 will give you 0. So in order for this limit to exist, this x squared minus x plus k has to factor with x minus 4. Okay? So if I plug in 4, I have to get 0 from the top, basically. So 4 squared minus 4 plus k. Oops. So 4 squared is 16 minus 4 plus k. 16 minus 4 is 12. 12 plus k, that has to be equal to 0 in order to get 0 over 0. So k equals negative 12. Okay? Now, if you do that, if k equals negative 12, then this factors, and then it's going to cancel the x minus 4. Okay? But we're not looking for the value of the limit. We're just trying to identify what k will make this limit exist. Here it says the function t of x equals 2 to the power of x minus absolute value of x minus 3 over x minus 3 has. Okay. Clearly, x can be 3, right? By definition. Therefore, we have a discontinuity. Now we need to identify which one is it. So it's not D. Okay. Now, absolute value, remember, we gotta break it into 2. So t of x becomes 2 to the power of x minus 3 over x minus 3. For x greater than 3, 2 to the x minus negative x minus 3 over x minus 3 for x less than 3. Okay? Now this becomes 1, so I'm going to simplify it over here. So 2 to the x minus 1, this becomes plus 1 for x greater than 3 and for x less than 3. Now, if it's a removal of discontinuity, the two limits from the left and from the right are equal. But clearly you can state that they're not, because one is subtracting 1 and then the other one is adding to 1. So it's definitely C, a jump discontinuity, because the two limits are not the same, and it's not B because it's not infinity. Okay, so, and clearly this one is off the charts, so C. Which of, this is number 4, oh, actually it's number 5. So 5 here, 4 here. So which of the following functions is not continuous for all real numbers of x? Okay, therefore we're looking for discontinuous. Okay, this is another type of problem that you need to address when taking the AP. Change the words so they make sense to you. Okay, not continuous is the same thing as discontinuous. So the question is, which of the following function is discontinuous for all real numbers of x? Okay, x to the power 1/3 is continuous everywhere, so it's not that. B is continuous everywhere except at -1. Okay. F of x, this is continuous everywhere. Here it's only continuous for 1 plus e to the x greater or equal than 0. Okay. Now e to the x is greater or equal to -1. That is true for all x in the reals. Okay, so it's not that one. X squared plus 9 will never gives you 0. Okay, so it's not that one. Therefore it's B. Okay. Now, I don't want to confuse you with this statement because it's actually not the same thing. Not continuous for real numbers x means that it's discontinuous at a real number x. Okay, discontinuous at a real number x, and the number that is discontinuous here is at -1. Okay, so that's 5. Number 6, limit when x approaches 1 of ln of x over x. Notice that if I plug in ln of 1 over 1, ln of 1 is 0 over 1, which is just 0. So it's B. Here we have to do some sort of manipulation. Tangent of x is the same thing as sine of x over cosine of x and then over x. When you have a fraction over a fraction, right, x over 1, we multiply by the reciprocal of the denominator. So sine of x over cosine of x times 1 over x. Now, remember the theorem, okay? It's when the sine of x is over x. So I'm going to remove the cosine and switch it with the x. So this is the limit when x approaches 0 of sine of x over x times 1 over cosine. Why can I do that? Because multiplication is commutative, okay? You can switch them around. Now this becomes 1. Cosine of 0 is not 0. Cosine of 0 is 1. So this is 1 over 1. And 1 times 1 is 1, okay? Which is E. And that's, which problem is this? 7. Let's go to the next column. Here it says, find the values of C so that the function is continuous everywhere. Well, it is continuous everywhere except at 2 where there's a potential danger. So I'm going to take the limit when x approaches 2 from the left of h of x and equal it to the limit when x approaches 2 from the right of h of x. Okay? And that has to be equal to f of 2. Now from the left, I'm going to choose the top one. So limit when x approaches 2 from the left of c squared minus x squared equals, well, we plug in for x, so you get c squared minus 2 squared, which is c squared minus 4. That has to be equal to the limit when x approaches 2 from the right which is also equal to f of 2. From the right, we're using this one, and for f of 2 as well. So that has to be equal to x plus c, but if I plug in 2 for x, I get 2 plus c. Okay, so we have c squared minus 4 equals 2 plus c. This is a quadratic that we need to solve, okay? So we equal it to 0. Z squared minus 4 minus 2 minus c equals 0. Z squared minus c minus 6 equals 0. We factorize this. 2 factors of negative 6 that when you add them gives you negative 1. It will be negative 3. No. Negative 3 and positive 2. Okay, so this is going to be c minus 3 and c plus 2 equals 0. Therefore, c equals 3 and negative 2. So 3 and negative 2. 3 and negative 2. There it is. C. Okay? Next one. Limit when x approaches 0 of 1 over x plus 1 over x squared. Notice that if I find a common denominator, it's going to be x squared. So it's going to be x plus 1 over x squared. Now, remember, this limit must be, if it exists, is because from the right and from the left are both equal. From the right of 0, you plug in from the right of 0, this is still 1 over 0 from the right. That gives you positive infinity. You plug in 0 from the left, okay? This is still 1, but it gives you 0 squared, which is still positive infinity. Therefore, your answer is positive infinity. Next one says, suppose f is defined here. Then the value of k for which f of is continuous for is same style as the previous two. Okay, we need to find the limits. Here it's x not equal to 2. Therefore, from the left and from the right is both this function. So basically, here we only have to find the limit when x approaches 2, which is the absolute value of x minus 2 over x minus 2. And that has to be equal to f of 2, which is just k. So need to find this limit first. Now, same deal with the absolute value. It's a piecewise function by itself. So absolute value of x minus 2. Now, we only worry to break it into 2 if this gives you 0 over 0, which it does. That's why we have to break it into 2. Okay? So it's going to be x minus 2 for x greater than 2. I mean, that's 0. Greater or equal than 0. And then, over x minus 2. And negative x minus 2 over x minus 2 for x less than 0. Okay? But notice that 2 is greater than 0. So we're finding it to be this one. Okay? We don't have to worry about the second one because it's for x less than 0 that we have to use this one. So both direction of 2, which is what we're looking for at the limit, we're going to use this one, the top one, okay, which is equal to 1, because x minus 2 over x minus 2 is equal to 1. Therefore, 1, which is the limit, has to be equal to f of 2, which is k, okay, which is d. Next, last one, says which of the following is continuous at x equals 0? At x equals 0, 1 is continuous. At x equals 0, e to the 0 is 1, which is also continuous. Here, notice that ln of e to the 0 minus 1 is ln of 1 minus 1, which is ln of 0, which is negative infinity. Therefore, is not continuous at 0. Therefore, 1 and 2 only. I know it was pretty fast, okay? But this is the speed that you want on your AP testing. Okay? Notice how fast I attack the problems because of how I already know what to do before I even look at a problem, okay? So this is the speed that you want on the AP testing and the accuracy as well. If you like the video, please subscribe to Motivout. Let me know if there was something that you didn't like or did like, comments below, and I hope you enjoyed it. Thank you.